Today, our objective is review our understanding of how to evaluate rational expressions, aka fractions, when they have radicals in the denominators. Boo. We don't like that. All right, the first thing I want you guys to do is take some time to work on those 6 problems right there as your warm-up. Ready, set, go. I know some of you may be just confused on what's supposed to be happening here. I'll just do number 1 to jog your memory. 72. The square root of 72 is the square root of 36 times 2. Do we all agree? The square root of 36 times 2 is the square root of 36 times the square root of 2. So we can separate them and we can glue them back together. It goes either way. Square root of 36, that's something we know. 6 times the square root of 2, that can't be simplified anymore. So that's the type of answer I'm looking for. So hopefully that helps you out. I know I saw a little bit of confusion there. All right, let's talk about it. Number 2, simplify square root of 50. Can someone talk me through kind of what I did with number 1? Someone talk me through it? Alex, let's see it. Yeah. 5 square roots of 2. You are exactly correct. Number 3. John, yeah? Square root of 100 and square root of 2 can be separated. 10 times the square root of 2. Very nice. Do we all see that? All right, multiply the square root of 100 times the square root of 100. Billy, did you get that one? No? John? Both. Let's hear it. Right. So if you multiply these two, actually, it's okay. So, and then what'd you do? Square root that, which gives you 100, right? Okay, what was your other way? Yeah, so the way that it's easy to see that is if you think about like 2 times 2, that's 2 squared. So it's no different here. The square root of 100 times the square root of 100 is a square root of 100 squared. The square root and squared, those are inverse operations. They do the opposite thing. So they cancel each other out, and you just get 100, which is kind of what Jonathan was saying about multiplying. So now if we look at number 5, Billy, what do you think about number 5? It's 8. Yep. You are exactly right. The other thing you can do is multiply what's underneath the radical together. So you could have gotten the square root of 64, which is also 8. Very good. All right. This looks messy. Let's clean this up. Chase, do you know how to do this one? No? Do we have any ideas? So we can do this, we just need to maybe switch some things around. Yeah. Well, the bottom is 3/4. Well, so if I multiply the bottom by 3/4, it doesn't cancel out quite. But I like what you're thinking about canceling things out. What would make that cancel out? If I did 1/2 multiplied by 4/3, that's multiplying top and bottom by 4/3. That would cancel out the 4's and the 3's. And on the top, you're left with 1/2 times 4/3. Do we see that? Does that make sense? So if we have, maybe if I write it out, it'll be better for everyone to see. If I multiply the bottom by 4/3 and the top by 4/3, these 4's cancel. That's a factor of 1, 4/4. The 3's also give you a factor of 1. You're left with nothing in this denominator and just these 2 fractions. And that's why we always say multiply by the reciprocal. because when you divide two fractions, that's what it will end up being. You're multiplying by the reciprocal. Now if we have two fractions, what do we do? How do we do that? You just multiply straight across the top, straight across the bottom. So we got 4 over 6. Is that an answer that we leave? No? Yes? Yeah. Oh, what do you, yeah. So if you did, you'd still have the 3 in the denominator. You'd have 1/2 over 3 though. And the whole idea is making it so that it's not a complex fraction with like multiple division signs. See, there's 3 here. If you just did multiply by 4, you'd cancel that out, but this would still be here. So the reason we do both is so that both cancel out and we just have to work with multiplication. But does it make sense what we're doing here? Okay. So this isn't our final answer. This is no good. This would be marked wrong. Why? Yeah, Norman. It's not reduced. We need to reduce, okay? We can pull out a factor of 2 from both, so we are left with 2/3. That, in fact, is our final answer. Are we clear about our little warm-up there? Yeah? All right, we are moving on. So those aren't the type of questions that you're going to have. You're going to have questions about the unit circle and sine and cosine and tangent, where you might have a complex fraction or you might have a radical in the bottom. And so we're just reviewing it because you're going to need to apply your knowledge about sine, cosine, and tangent, and you might have an answer with a radical in the bottom, and that might need to be reduced in order for you to get the right answer. So this is just like little steps that need to be taken. We're just trying to clean up your skills, maybe remind you of how to do all this stuff. That's why it's called radical review. So hopefully some of this stuff comes back when you hear it. Our one and only vocab word for today, conjugate. I've said it before, we've worked with it before. We are just reminding you again. A conjugate is the expression that we use to get rid of radicals in the denominator. It consists of the same numbers as the original denominator, but different sign as the original denominator. So I'm just going to write some expressions that might be in your denominator. What if you had square root of 3 plus the square root of 2 as your denominator? What's the conjugate to that? Does anyone know what the conjugate of square root of 3 plus the square root of 2 is? Well, I'll tell you. Looks like that. What are we missing? If we have the same numbers but different signs. What's that middle one? Right? What goes right in between? So it says, but different signs. Minus sign, yeah, exactly. So same numbers, just that different sign in the middle. So what if our denominator is 2 plus the square root of 2? Our conjugate is 2 minus the square root of 2. That's all the conjugate is. And you'll see later when we do examples why we need to use the conjugate to get rid of the radical in the denominator, how it helps us to get rid of the radical in the denominator. Are we clear about what the conjugate is, though? Yeah? Nods? Yes? We're good? Okay. All right. Example 1. We are simplifying some expressions here. We have some gross radicals in the bottom that we need to get rid of. What needs to happen here? What should we multiply by? Not the conjugate. We don't have a plus or minus in the denominator here. What do we multiply by? Square root of 2 over square root of 2. It's just a factor of 1, guys. So if we multiply across the top, 3 square root of 2 over square root of 2 times square root of 2. Billy, what's square root of 2 times square root of 2? 2. That is our answer. Very good. All right. I could multiply top and bottom by the square root of 16. Could I not? Wouldn't that work? But what do you notice? Yeah, square root of 16, we know that. That's a number. That is 4. We do not need to do all that extra math if we see something like that. Square root of 640 over 4. So the only thing left would be to maybe check out what's going on with the square root of 640. Do we know? Alex, yeah. 64 and 10, you were right. The square root of 64 times the square root of 10, we can split those up all over 4. We know that the square root of 64 is 8. Square root of 10, there's nothing in there that can be simplified further, so we're just left with square root of 10. And it's all over 4. Is that our final answer? Can I box this? Are we done? No. I heard a no. Why not? Chase, why not? Yeah, the 8 over 4, that's just 2. We need to simplify. That looks like our final answer. Do those two make sense? Do A and B make sense to you guys? If so, I see some nods. If so, I want you to try part C. There's more than one way to do this, just so you know. So give it a try. Make sure you're on track. And I will walk around and see if there are any questions. Let's take a second to look at the shortcut here. This is one way to do it, definitely. Shortcut, did you notice how we're kind of separating and gluing back together a lot with the multiplication under the radical? Yeah? You can do that with division too. So we could rewrite this. Okay, that's not what I want. We can rewrite this as the square root of 972 over 486. Can someone type just the inside, just the radicand? Yeah, 2. It's 2. Look at that. We did all that. We could have just done that. See, there's multiple ways to do it. Either way is right. It's nice to see the short way, obviously, but there's more than one way to do it. I saw you got that. Very nice. All right, moving on to the next page. We have some more examples that we're going to do. I'm going to start by doing, we'll do B together. We're going to do B together, and then you'll get a chance to try A by yourself. Oh, no, I'm not doing A next. Just kidding. Okay. Well, actually, I'll let you guys pick. What do you see first? What's something that you want to do with this problem? Well, we're not doing A together yet. We have to do B first, but I'm asking you what in part B. What's the first step? Who wants to get us started in this problem? Yeah, Jonathan. Yeah, using a conjugate. Okay, so you would do square root of 72 minus square root of 8 all over square root of 72 minus square root of 8. We have to remember, yeah, we still are multiplying across the top and multiplying across the bottom, but we have to remember these are little expressions here. They have pluses and minuses in them. These are all expressions. So when you see 5 times this, it's not 5 square roots of 72 minus square root of 8. It's 5 times this whole quantity, which means we need to distribute that 5 in to the top. So 5 square roots of 72 minus 5 square roots of 8. What do we need to do in the bottom? What's that word? FOIL. I heard it. Yes, FOIL. We need to do it. It's not as messy as it looks. I promise. It looks really gross. It's not. First, our first terms, square root of 72 times square root of 72. What is that? 72. All right. Our outers, that's negative square root of 8 times the square root of 72. Our inners is add square root of 8 times the square root of 72. And our lasts are what? What are our lasts? Positive square root of 8 times negative square root of 8. What does that leave us with? Nicole, do you know? Negative 8, exactly. Very good. So, what do you maybe notice about what happened there? Anyone seeing it yet? Seeing it? Yeah? John, what do you see? Yeah. They are opposites. Negative and positive of the same thing, that's just 0. And that should happen anytime you use the conjugate, just so you know. If you're doing it correctly, the inners and outers should cancel when you FOIL. So we are left with 5 square roots of 72 minus 5 square roots of 8 all over 72 minus 8. That's 64. Unfortunately, we are not done. What's wrong with what's wrong? What do we have to still do that's not simplified yet all the way? So we can't reduce like a common factor out. Square root of 8, square root of 72. What do we see? Yeah. Do you have an idea? They have to be simplified. The radicals, you're saying? Okay, yeah, I agree. All right, the radicals have to be simplified. All right, so I see the 72. That can be split up into the square root of 9 times the square root of 8, right? And I'm just going to leave that second part the same for now. All over 64. So the square root of 9 is something that we know. The square root of 9 is 3. So we have 3 times 5 times the square root of 8. 3 times 5, 15 square roots of 8 minus 5 square roots of 8 all over 64. 15 square roots of 8 minus 5 square roots of 8. If we have 15 of them and we take away 5, this is the only time, by the way, that you can add or subtract, is if the radical is the exact same. You can add and subtract. So 15 square roots of 8 minus 5 of them. How many do we have left? 15 square roots of 8 minus 5 square roots of 8. What? 10 square roots of 8. Thank you. Thank you, John. I appreciate that. 10 square roots of 8 all over 64. Thank you, Chase, for that. Okay, what else? What else? This is not done yet. Yeah, John. Yeah, we still have to simplify the square root of 8. The square root of 8 is square root of 4 times square root of 2, or just 2 square roots of 2. So that's 20 square roots of 2. You see how I did that? I just multiplied that outside 2. All over 64. That can be simplified to what? 5/16. Wait, it's not 5/16. Is it 5/16? I think I got a different answer last time. No, I'm just recalling from last period, but you pull out a 4 from both of those, right? And then you have 5 and 16 left. Correct? Okay. Just checking. Are we done? Yes. You can box that. That is your answer. We are done. All right. For the sake of time, let's scooch down to D and do that one together. And then I'll I'll give you a chance to do A and C independently with whatever time we have left. So D, I would use a conjugate, yeah. We have a addition or subtraction sign in the denominator. We also have a radical in the denominator. That's the main reason. 2 square root of 6 plus 7. Top and bottom. All right. We have some distributing to do. Four times 2 is 8. 7 times 6 is 42. 4 times 7 is 28. Square root of 7. On the bottom, our firsts are 2 square root of 6 times 2 square roots of 6. That is 4, right? 4 on the outside. Square root of 6 times square root of 6. That's just 6. 4 times 6. I'm going to rewrite that as 24 for you guys. 24. Our inners and outers cancel. Yeah. Our lasts are, what is our lasts? What? Yeah, negative 49. You are correct. Eight square roots of 42 plus 28 square roots of 7 all over negative 25. Let's take a good look at this. These numbers seem pretty big. Can we even simplify anywhere? Is there anywhere? Square root of 7, nothing can be done with that. There's not a common factor in 8, 28, and negative 25. We can't pull out a factor of 1. Square root of 42, that's just 7 times 6. That's 21 times 2. There's nothing. There's no perfect square in there, right? So as weird as this kind of looks as our answer, this is done. We checked all the pieces that could possibly be simplified. We are done. So I want you to take the last 5 minutes or so to try A and C. I'll walk around to make sure everyone's on track and maybe answer some questions that you can check your work with me. But that'll finish up notes for today. Your homework is just the pages after, which they're 2 pages. It's just more radical review to make sure that you are good. So those are your homework, and if you don't finish A and C in class today, that's homework too, because you need to make sure all your notes are filled out for notebook checks and such. So work on A and C, and if you get done with that, you can even start your homework.